Okay, we're now recording. Good morning. This is Dr. David A. Padgett. This is Weather and Climate, Geography 3500, February 2nd, 2021, Groundhog's Day. And the groundhog, Puxatawny Phil, uh, saw his shadow this morning. So I guess we're going to have 6 more weeks of winter, if you believe in that kind of thing. Anyway, so this week, our mission is to complete this weather data mapping exercise, and we might have to make some adjustments, perhaps not. Um, and so hopefully we will be done in time for us to, again, engage with the Detroit area middle and high school students. So as you know, a portion of this class is service learning. And so our service is for you to serve as examples of excellence and achievement as you all are in college. And these young people in Detroit want to be where you are in a few years. And by engaging with them in this activity, hopefully that will push them toward that goal. And so the students in Detroit are doing an exercise very similar to the one that you're doing. It's watered down a bit, and so but it is very similar. Using some of the same data. Okay, so let's launch right into the activity. So here's the assignment, weather data mapping GIS exercise, and we're going to download the assignment here. And so what we're going to be doing is working with globe data, and we learned last time global learning and observation to benefit the environment, or the GLOBE program, is a NASA funded and federal government sponsored program that has as its goal to improve K through 12 education in science specifically. And so there are GLOBE schools all over the world. And so we're working with some schools in Detroit. And so here is a screen capture from the GLOBE visualization system, these various schools. And so what we're going to do is get current temperature data for June, July, and August 2019 collected at some of these sites. And so then we're going to take those data and create a map. That's one of the things that you're going to do, and that the students are also doing, the high school students. Secondly, we're going to take some of the visualizations from the GLOBE site, specifically this temperature climograph for June through August of these years, and we're going to create a story map using the images. So that's one of the goals, or two of the goals that we're going to hopefully accomplish this week. But of course, the first thing that we're going to do is we're going to create a map using the data that you collected during assignment 1, which of course is going to lead to some issues right away. So what we're going to do today is go back and look at some of the data that were collected by students last week, and then we're going to convert those data into a GIS attribute table. But the first thing that you're going to have to do, if you haven't already done so, is create an ArcGIS public account. So I'm going to walk you through that right now. If you don't already have an account, go here. And we're going to open up our browser to the ArcGIS. Well, this is the Environmental Systems Research Institute, ESRI, webpage for their ArcGIS Online accounts. And so what you want to do is create a public account. Don't do the trial account. The trial account only lasts for 21 days. What you want to do is create a public account. And you click there, and then just go through the procedure for getting a public account if you haven't already done so. So then after your public account is established, we'll be ready to move forward. So what I'm going to do while either you're establishing your public account right now is I'm going to move forward in building the attribute table, or we're going to do that. Now, of course, Theodora, you don't have any data yet, so we'll talk about that on the back end of this. So I'm going to go and search for the attribute table that we need. And so, Geography 3500, spring 2021. Okay, so here is the outdoor weather data collection sheet. So if you're watching this recording, here's what we are going to do collectively. Okay, so I'm going to go to my Google. One of my Google accounts. Go here, go to Google, and then I'm going to upload this document to my drive. Let's see, do I have a drive for Geography 3500? No, I don't. So I'm going to just upload this file straight into the drive. So there it is. And then I'm going to share this sheet and make it so that anyone with the link can be an editor. And then I'm going to copy this link to the course webpage. I'll have to get out of student mode to do that. So just showing you where everything is. So the actually, I'm going to put it right here with the assignment. So that everybody will have access. Here, edit folder. Outdoor weather data. Data collection spreadsheet. Okay, so here's the link to the spreadsheet. Okay, so now what you should do, or what we're all going to do collectively, and I'm going to do some of this today for those of you who aren't here. So I'm going to go back into student mode and then go back to the assignment and then go here. And then I'm going to open up the outdoor weather data collection spreadsheet, which is a shared spreadsheet. Okay, there we go. And I'm going to open that with Google Sheets. And now the sheet should be editable by everybody. So I'm going to go into the Dropbox. Well, I'm gonna have to get back out of student mode. I'm going to go into the Dropbox and I'm going to get the data for that some of you all submitted last week. And so let's see. So here's okay, so Garrett, since you're here, you can just follow along with what I do. Okay, so I'm going to take Ashley's data here. And let me go back. Let's see what this is. Okay, so for example, let's see, looks like I'm going to have to download this. So if you have your data sheet, so what we're going to do is transfer some of the data from these data collection sheets into the shared spreadsheet, just like this. So let's go back to the shared spreadsheet. And so we have name, and the name in this case is, Michael Ashley. So we'll just call that Ashley M. Let's see, I don't know where he is. Oh, he's in Nashville. And his location is, let's say TSU. Well, he was very specific. He said TSU New Resident Complex. Oops. Okay, so now latitude and longitude. Oops. What the heck's going on here? Okay, I am obviously, this is the file that's on my hard drive. Sorry about that. Close that. No. Okay, oh, Jesus. Okay, this is where I want to be, in the shared spreadsheet. All right, there we go. Whoops. All right, let's try this again. Okay, so we want to be in the shared spreadsheet. And it updates automatically. Okay, now latitude and longitude. Let's go back into the students' data. I don't think lat long is going to be here. But the latitude and longitude is in this, somewhere in these submissions. At least they should be. Okay, blah, 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 blah. Okay, where's, okay, here is, no. Okay, let's see. Maybe he put lat long. We'll get this latitude and longitude from somewhere. See, maybe it's here. Okay, no latitude, longitude here either. Okay. Let's see, maybe he, it's not there. Okay, now here we go. Yeah, he got latitude and longitude. Good. Okay, here it is. So I had to keep looking for it. Okay, so his latitude and longitude. Shoot. Oh, here we go. Okay, good. He's got decimal degrees here. Thank goodness. So it's 36.17350. 36.17350. Now, so I'm just going to write this down just so I won't forget. So his latitude is 36.17350 degrees north, and longitude is 86.81983 west. So latitude 36.17350. Longitude is negative 86.81983 degrees west. And let's see, it looked like he did get the current temperature. From somewhere. I don't know whether we got the, let's see, got the temperature in here. Looks like it says 26 degrees Celsius, but that cannot possibly be right. Or maybe it is. Maybe it is. Depends on the day. We did have some warm days. And it says that's really warm. 26 degrees Celsius. On January the 30th. I don't know. Oh, this is what he said he got. So I guess that's what's going to go in here. 26 degrees Celsius. Look at some of his other data. Let's see, KNT. All right. I'm going to pause the recording here just for a second. Okay, so we took a second look at Ashley M's temperature data, and we corrected it to 3.3 degrees Celsius. So we were recording in Celsius degrees. The current temperature you would get from your National Weather Service site, and Let's see, don't have that. Okay, so we're gonna have to go back here again. And let's see if it was here. No, here. No, here. Yes. Okay, his National Weather Service station. It was either, I know it was either John C. Toon or well, pretty sure it was John C. Toon. Um, anyway, we'll go back to that later and get the rest of his data. From the cloud chart. Okay, so the remainder of the data are, let's see, his cloud cover percentage is 90 to 100%. So we'll use that. So we'll just do 90 here. Just keep it to whole numbers. Don't put the range. Just take the lower range. Let's see, what kind of cloud types did he see? He saw a little bit of everything. He saw no snow. No, he saw alto stratus, stratus, cumulus, stratocumulus. All right, so he saw. So this is exactly how you should fill your data sheets in. Let's see, I'm trying to get to it. Okay, so he saw alto, and you can just type all of them in. Alto, stratus, stratus. Just adjust the width. Let's see. Alto, stratus, stratus, cumulus. It looks like he saw strato. Looks like those aren't going to wrap, but that's fine. If they don't. And then I think the time we said was 7:30 a.m. I think he was out there at night. He wouldn't have seen any clouds. We just have to assume that that's the time. And so each of you should do exactly what I'm doing now. Take the data from your week one data set and enter them into this shared data table. So So I know, Theodora, you don't have any data. We've got Ross here. And so, Garrett, can you let's populate the spreadsheet with your data. Can you share what you have?
City was Nashville.
Okay, that was easy. So what was your location? Approximate?
Like a new health science building.
Okay. That gives us a frame of reference. What was your latitude?
Like 36. Yeah, 36.16. 73478.
And your longitude?
Negative 86.83. 14408.
And what current temperature did you get in degrees Celsius from your local weather station?
I think it's like 16 Celsius.
16 degrees Celsius?
Yes.
Okay. You know, I'm gonna add a field here if I can. Why I didn't before? Very important that we add a field. And that field is gonna be date. Why I didn't have that in there before. Date, and the date, I think he was okay, so we'll get to that later. Oops, shoot. Okay, so back to did you get a temperature for your local weather state for the National Weather Service station, or if not, don't worry about it. But we
I
can
had a link
get.
to it.
Oh yeah, but did you record the temperature?
Yeah.
Oh, what was it?
I'm trying to quote the link.
Oh yeah, don't worry about it right now. Just
I don't have it, yeah.
we'll get it later. What was your cloud cover percent?
Tell me what I said or what NASA said.
Oh, I mean, what percent did you get?
I said like 10 to 25%.
25%?
Like 10 to 25.
Okay, well, yeah, we'll take the low end of that. And what cloud types did you see?
Sirius. Yeah, Sirius.
Cirrus. What was the other one?
The Autostratus. And the Cumulus. Yeah, that's all.
Okay, and then the time. What time did you make your observations?
10:30 a.m.
2:30 in the morning?
No, 10:30 a.m.
Oh, 10:30.
Yes.
Oh, okay. And what was the date?
January 26th.
Oh,
No,
January.
January.
Okay, so thank you very much. So okay, so now we have we're populating our shared spreadsheet. And of course, Theodora, you'd have to so you're still not able to get into the course e-learn page. Yeah, Theodora. Okay, I guess she stepped away for a moment. Okay, so now what we're going to do is we're going to take the data that we have here, and I'm going to demonstrate to you how we will, or you will, create a map. But this is just a demonstration. So we've done this step here, we've collected our attribute data, but what we wanted is for the rest of you all, just as you've seen here, to take your data from assignment 1 and enter into this shared spreadsheet. Okay, that's so next we will take the globe weather data collection worksheet and convert it into CSV format. So that's the next step. So I'm going to go to File, Download. I'm going to download it as a Microsoft Excel spreadsheet first, just for our records. So here it is in Excel. And now I'm going to go to File, Save As. I'm going to save it into my GEOG. I'm going to call this Outdoor Weather Collection Sheet, GEOG 3500, Spring 21. And I'm going to hit Save. And so now here's the spreadsheet. One of the things I'm going to do is I'm going to format these cells as number cells, and these are the lat long cells. I'm going to make sure that we have at least 8 places behind the decimal, just for our purposes, so that they don't get truncated as we process the data. Everything else appears to be okay. And so now we're going to take this spreadsheet, File, Save As, and I'm going to save it as a comma delimited CSV file. And I'm going to get a bunch of error messages. Now I'm going to close it. Then a bunch of just keep saying yes, okay, yes. Now it's saved. Now I'm going to go into my ArcGIS Online account. Okay, I'm going to go to my ArcGIS Online account. I'm going to sign in. And this is what you should do. Then go into your map, and you'll get a blank map like this one. Then go to Add layer from File, and all of this is in the directions. I'm just walking through for you. GEOG Spring 2021. Here is the outdoor weather data collection worksheet we just created in part. Import that layer. Okay, and so now you see we're very zoomed in on TSU's campus. So we see where the two, let's see, if I go to name first and go to my legend, we can see that here's where Ashley M or M. Ashley and Ross G. collected their data on Tennessee State University's campus. Now, hopefully, soon we'll have everybody's data. I'm just doing this as a demonstration. And so next, you're asked to answer some questions. Is there a relationship between the clouds observations and the current temperature observations at each student site? In other words, if you look at the clouds, look at the current temperature observations, do you see anything, any relationships there? So for example, you would click here, Ashley M, his current temperature was 3.3 degrees Celsius, and his cloud cover percent was 90. You know, you see, maybe here, this looks like a much warmer day, less cloud cover. So you can start to see something there, less cloud cover, warmer temperature, much warmer temperature. Different cloud types, very high clouds, perhaps, and a few low clouds. We can also change the attribute that's shown to, let's say, current temperature. And so once we change it to current temperature, we can see that we get proportional symbols. And so here is Ross G's observation, 16 degrees Celsius here. And then we also have over here 3.3 degrees Celsius. But you notice that we have a different time of day. So I'm pretty sure that Ashley M was out early in the morning and got a relatively cooler temperature. And of course, the dates were different. And if we really wanted to investigate, we could go back and look at those days historically on the weather stations and see if indeed, let's see, maybe let's take a look. So this was January 26th. Let's look at January 26th. Okay, so January 26th. Oh, it was a very unseasonably warm day that day. And so when Ross apparently was outside at 2:30 p.m. and got about 16 degrees Celsius, then that's, excuse me, about 2:30 p.m.
10:30. Oh, 10.
Oh, did you say, oh, 10:30 a.m.?
Yeah.
Okay, yeah, so 10:30 a.m., 59 degrees Fahrenheit. If we were to convert that, yeah, we get exactly what you said. You got approximately about 15, 16 degrees Celsius. Perfect. So next you should save your map. I'm going to save this as GEOG 3500 spring 1 assignment 2 tags weather climate. I'm going to save, be sure you save your map. And I guess I will share this map as a demonstration of what your map should look like. So I'm going to make it public here. And I'm going to go here see, I'm not in student mode. So I'm going to go to the assignment folder and add this as link. Call this sample weather data map. Or, yeah, it's a sample right now, but anyway. So what we should be doing now, or you should be doing now, is getting into this shared document. And so 3, 4, 5, 6, 7. I think there are 7 of us or you in this class so far. And so just as you've seen demonstrated here, complete this table. And once we get as many of you all that completed assignment 1 to enter your data here into this shared spreadsheet, then you download it, convert it to the CSV, and then pull it into your own ArcGIS Online map so that you can then answer these questions while navigating around the map. And so that will be part 1 of this assignment. Okay, so part 2 of this assignment is to create spatial data visualizations with the Detroit area globe data. And so the globe data are displayed here and here. And so what I did, and just to give you an idea of the source of the data, I pulled the data off of the globe sites for Detroit, and these are globe schools in the Detroit area. And so the students are looking at urban heat. So they're looking at the impact of urban heat upon human health and ecological health. So that's their main objective. The students, I mean, that you will hopefully be interacting with on Saturday. And so I'm just showing you the data set just so that you'll know the original source of the data. So I'm not going to give all this to you. I'm just going to show you what had to be done. So this is the raw data from one of the weather stations. And so you'll notice in the field, you have a number that is the organization ID number, then the name, in this case, Crestwood High School. Then there's a globe ID attached to the weather station, the name of the station, the latitude, longitude, and elevation, the date of the measurement. So notice these measurements are approximately June through August of 2019. And so this particular weather station was collecting data looks like almost every hour or so. And so here are the data in degrees Celsius for June through August at this site in degrees Celsius. And so in order to get the average temperature in degrees Celsius for the months of June through August, and the reason obviously we're looking at June through August because those are the warmest months of the year in Detroit. Those are the dates of concern in terms of urban heat. And while we're on the topic, heat kills more people than any other weather hazard. Kills more people than hurricanes, more people than tornadoes, flooding, so on and so forth. Um, so what I did was I extracted the data from this large database, and I broke the data down into individual spreadsheets. So here is the Crestwood High School cicada site data. And so I went into this data table, and here are the temperatures that were collected at this cicada site for approximately June through August 2019, added them up, and then divided this number, which is the total for temperature, divided by 63 observations. And I then entered that number into this spreadsheet called Detroit and Toledo area globe current temperature data, June through August 2019. And so here, so I'm just showing you where this data table came from. So we have these various temperatures, and we have the site names, latitude and longitude, and so on and so forth. So your mission, should you choose to accept it, is I'm going to take this data table and I'm going to save it. I'm going to add it to the assignment 2 Dropbox folder. And so now that you have the data for this particular mapping assignment, and you presumably have the instructions for how to do the mapping, your assignment is to take this data table and add it to your map. Now, I'm going to go ahead and demonstrate that for you, but I'm not going to save the map. So what we would do is, again, we would go to this map or your empty map, click add layer from file. So of course you'd have to convert that table into, you know what? I have not converted that table yet. So where is it? Here it is. So I would go to file, save as, and then save it. Let's see, go. Yeah, I'm going to save it as a CSV file. And then I'm going to close it. And now I'm going to pull it into this map. Add layer from file, choose file. There it is, right at the top. Open, import layer. Okay. And so now we have, as you can see, if we just take the first iteration, we have our 5 schools. I see 6 schools on the map. What's going on? We have our schools that are in the Detroit area on this map, and we can then go into content and change the visualization to average temperature degrees Celsius. And now we get a better idea of some of the variation in temperature. So really, most of the sites don't have a wide variation in temperature. But then you have this one site here at Crestwood High School. And so this is where you might want to change the base map and zoom in on that site and look at what's going on. Why is Crestwood High School so warm? Well, the first thing you're going to notice is that the lat long is a bit off. I'm assuming that this is the high school, so the weather station is probably on this campus, but the latitude and longitude clearly is a little off. But yet and still, you have a lot of hard concrete surfaces here. Lots of things that could influence the temperature of the, that could drive it to 26 degrees or slightly higher than the other schools are recording for the same month. So again, these are the average temperatures for June through August at these 5 sites. So you should follow these instructions to create a map of the Detroit area Globe Partner schools. And so here are the instructions. And then answer these questions. Is there a relationship between the current temperatures at each Globe site and distance from Detroit City Center? Is there a relationship between the current temperatures of each site and the surrounding land cover? Do you notice anything else that might have influenced the current temperatures at each site? So what you're looking at are the differences in temperatures at each site. Then add the urban heat islands for US cities layer to the map. And so you would go to add, search for layers, and then you want to go into maybe ArcGIS Online, urban heat island. There it is, urban heat islands for US cities. Let's see, I think that's the most recent one. Let's just try it. Click there, click add to map. And then you see the layer is added in, and you can, so here's the urban heat island layer. So these are indicators of urban heat, or this is a database or data layer created by looking at ground observations and satellite observations, which gives us indications of which parts of cities are hotter than others. And we can make note of the fact that in places where, or neighborhoods where cities are especially hot, there are various health issues associated with that, including increased adult and childhood asthma attacks for COVID-19. These neighborhoods it increases the susceptibility and vulnerability of populations in these hot areas to COVID-19 because it's a respiratory illness, and so high temperatures can potentially cause respiratory stress through the development of ozone in the troposphere, and we'll talk about that later. But let's see, do we see a relationship here? I mean, clearly Crestwood Middle School is right in the middle of one of these hot spots, whereas this school, Hearn Valley High School, its weather station looks like it's in a relatively wooded area. You can see the trees. Anyway, before I give away too many of the answers here, that's the assessment or analysis that you should make as you answer these various questions. Um, the last thing we're going to do, probably pick this up on Thursday, is create a story map using the current temperature data. So again, just to review, your mission for this assignment is first to finish populating the shared spreadsheet here with your data from assignment 1. Don't worry about the National Weather Service station data. Maybe we'll, in a discussion, get those data. Maybe we will, maybe we won't, but we'll see. We can get it from the National Weather Service archive data. But again, everybody needs to populate this sheet, your name here, your data from assignment 1. If you have not completed assignment 1, let me know, and I will we'll work that out one way or the other. Assignment 1 is due, I believe, today. So I'm going to before I close out, again, your instructions. At the end of this, you will have 2 maps, or 1 map with 2 layers on it. 1 layer of you go back in and add that layer. Now notice that your outdoor weather collection data, even though that it's going to be on the same map, is going to appear as an additional layer. But of course, obviously, this layer, who knows where it's going to be? It's all based upon where each of one of you is located after you've add your data to the spreadsheet. And so again, I'm probably going to ask that you save your links to your maps also. I don't know why I didn't have that in there, but we'll see. Okay, so I'm going to stop the recording.